Okay, Assalamualaikum warahmatullahi wabarakatuh and good day. Okay, this one is for the example for the Flexure formula. Okay, this one is for the example number 1. Okay, the equation for example number 1 is determine the absolute maximum bending stress in the beam, and the second one is to draw the stress distribution over the cross-sectional area. Okay, the equation give the UDL as a load with the value is 5 kilonewton per meter, and then the cross sectional area is the cross sectional is I beam. Okay, this one is I beam. Okay, so first you must find the maximum moment using the formula is WL squared divided by 8. Okay, this one. Why you use WL squared divided by 8? Because this one is for the formula for the UDL. Okay, so the maximum value is 22.5 kilonewton meter. Because this equation is to find the maximum bending at the center, so we don't need to find the centroid of beam section because natural axis is 0. Okay, after that, after you get the maximum moment, you need to find the moment of inertia. Okay, moment of inertia, you must use this equation. I equals to summation of I bar plus area time by d squared. Okay, so you from this equation, okay, you can divide into by by part for the cross section I beam. Okay, this one is part number 1, this one is part number 2, okay, this one is part number 3. Okay, so you can get the I x inertia is 301.3 times to power of negative 6 meter to power of 4. Okay, and for the last step for to find the maximum bending stress is using stress maximum equals to MC divided by I. Okay, so stress maximum, you use MC divided by I. M is moment, C, and then divided by I. I is moment of inertia. So moment, we use the maximum moment, bending moment, which is 22.5 times to the power of 3, and then C is 0.17 divided by moment of inertia that you calculate before this, 301.3 times to the power of negative 6. So that stress maximum equals to 12.7 megapascal. Okay, and then for the bending stress at the B, we use the equation negative my at B divided by I. I is moment of inertia. Okay, so you must remember these two equations. Okay, and then you can substitute this equation into m negative 22.5 times to the power of 3, yb is 0.15, and then moment of inertia 301.3 times to the power of negative 6, and then the stress B is equals to negative 11.2 megapascal. So we can conclude that negative for the stress B is compression. Okay, for the example number 2, okay, the equation is the beam has a cross-sectional area in the shape of a channel. Okay, you must remember the cross-sectional area is shape of channel. Okay, determine the maximum bending stress. Okay, maximum bending stress at the occur in the beam at the section AA. This one is section AA. Okay, so you can see this one. Example number 2, the beam is in a type of cantilever with the point load. Okay, and then this one is shape of channel. Okay, you can see shape number okay, several part number 1 and then number 2 is same size, and then part number 3 is different. Okay, so that one more thing you must remember, this one is point at C. Okay, okay, for the solution, okay, first you need to find the centroid of beam section using the formula y bar equals to summation of y bar time by area divide by summation of area. Okay, you can see this one in the equation 2. Why is it 2? Because part 1 and part 2. Okay, part 1 and then part 2. Okay, this one is part number 3. Okay, so you can get the y bar is 59.09 millimeter. Okay, and then the next step, you must find the moment. Okay, moment at the support using the equilibrium equation, which is summation of moment equals to 0. So that you can find that moment is 4.859 kilonewton meter. Okay, for the next solution for the example number 2, okay, for the next step is you must find the moment of inertia using the I equals to summation of I bar plus AD square. Okay, so the moment of inertia is 42.26 times to power of negative 6 meter to power of 4. Okay, and then the last step is you must find the maximum normal stress using the formula MC divided by I. Okay, M you use the moment at the cross sectional area. Okay, 4.859. Okay, C is 0.2 divide minus 0.05909 divided by moment of inertia 42.26 10 to the power of negative 6. So the maximum stress for this equation is 16.2 megapascal. Okay, that's all for the answer for example number 2. Okay, this one is you can see the other example in the YouTube that I suggest to you about the flexural formula. Okay, thank you so much. Assalamualaikum.